You are standing on the bank of a river. It is 100,000 years ago. The water is wide. The current is strong. On the other side, you see fruit trees. You can see the fruit from here. It is ripe. It is exactly what you need, but there is a problem. The river is between you and those fruit trees. You cannot walk across it. You cannot jump across it. You cannot jump across it. You have two choices. Or get into the water. You have never done this before. No one has taught you. You have no idea if it will work. But you are hungry. You step into the water. It is cold. It reaches your waist. It reaches your chest. Your feet leave the bottom. You panic. Your arms flail. Your legs kick. You push against the water, and somehow, impossibly, you do not sink. You move forward, you gasp for air, you keep moving. By the time you reach the other side, you are exhausted, but you are alive, and you have just done something that no other ape on Earth can do. You have swum. Let me ask you something. Why can humans swim when chimpanzees cannot? Humans and chimpanzees share 99% of our DNA. We are closer to chimps than elephants are to mammoths. Yet a chimp dropped into water will panic and sink. A human, given the same situation, can learn to swim. Not easily, not instinctively. But with practice, a human can become faster and more efficient in water than almost any other land animal. Why? What changed in the human body that made swimming possible? And when did our ancestors first figure out how to do it? These questions take us from the first puddles of ancient Africa to the Olympic pools of modern Tokyo, from the swimming reflex of newborn babies to the physiological secrets of free-diving champions. The story of human swimming is the story of how a land animal learned to move through a world it was never designed for. Let us start with the most surprising fact about human swimming. Newborn babies can swim, not perfectly, not for long, but put a newborn infant in water, and they will instinctively hold their breath and move their limbs in a swimming motion. This reflex disappears after a few months. It is not learned. It is innate. You have probably seen the videos on YouTube, newborn babies placed in water, instinctively holding their breath and moving their limbs. It looks like magic. It is actually evolution at work. Why do humans have a swimming reflex when chimpanzees do not? A 2013 study by Dr. Myrtle McGraw at Columbia University, one of the first researchers to systematically study infant swimming, argued that this reflex is a vestige of our evolutionary past. Some researchers believe that the infant swimming reflex is evidence that our ancestors spent significant time in water. Others argue that it is a general mammalian reflex, not specific to humans. The debate is unresolved. But the reflex exists, and it suggests that the potential for swimming has been in the human body for a very long time. Let me tell you about the aquatic ape hypothesis. In the 1960s, marine biologist Dr. Alistair Hardy proposed a controversial theory. Hardy argued that a crucial stage of human evolution took place not on the savannah, but in the water. He called it the aquatic ape hypothesis. The theory goes like this. Around 6 to 8 million years ago, when the ancestors of humans split from the ancestors of chimpanzees, some of those ancestors lived in flooded environments. They waded in shallow water. They dove for shellfish. They spent enough time in water that their bodies began to adapt. The aquatic ape hypothesis explains several features of the human body that are unusual among primates. We have subcutaneous fat, like dolphins and whales, not like chimpanzees. We have very little body hair, like aquatic mammals. We have a diving reflex that slows our heart rate. When our face is submerged, we walk upright, which could have evolved from wading in deep water. Most evolutionary biologists reject the aquatic ape hypothesis. The evidence is weak. The timeline does not match. But the hypothesis raises interesting questions. Why do humans have a diving reflex? Why do we have more body fat than other primates? Why are we the only ape that can learn to swim? The standard answers have nothing to do with water, but the questions remain. Let me tell you about the physics of human swimming. Why can humans float when chimpanzees sink? The answer lies in body composition. Humans have a higher percentage of body fat than any other primate. The average human body is about 15% fat. Chimpanzees average less than 5%. Fat is less dense than water. Muscle and bone are denser. More fat means more buoyancy. Your body is naturally designed to float, not perfectly, but well enough that with a little movement, you can keep your head above water. A 2019 study by researchers at the University of Southern Denmark used CT scans to model the buoyancy of human and chimpanzee bodies. The models showed that the human body is significantly more buoyant than the chimpanzee body. You float. Chimpanzees sink. That simple difference explains why you can swim and they cannot. Your upright posture also contributes to your swimming ability. When you stand in water, your body displaces more volume than a chimpanzee's horizontal frame would. That displacement creates buoyant force that pushes you toward the surface. This is Archimedes' principle, discovered by the Greek mathematician in the 3rd century BC. The same principle that keeps ships afloat keeps your body near the surface. But buoyancy is only half the story. Moving through water requires overcoming drag, the resistance created by your body pushing against water molecules. Water is about 800 times denser than air. Every stroke you take requires significantly more effort than the same movement on land. The human body has evolved several features that reduce drag. Your streamlined shape, your flexible shoulders, your long limbs, all work together to minimize resistance. The front crawl, developed in its modern form in the early 20th century, is the most efficient stroke because it keeps your body in a straight line. Your head stays down, your hips stay high, your arms reach forward in a continuous cycle. Every element of the stroke is designed to reduce drag and maximize propulsion. Let me take you to the earliest evidence of human swimming, the Cave of Swimmers. Located in the Gilf Kebba Plateau of southwestern Egypt, this cave contains rock art that is at least 8,000 years old. The paintings show human figures with their arms extended. Their bodies are horizontal. Their limbs are moving in what looks like a swimming stroke. These are the oldest known depictions of human swimmers, but swimming is almost certainly much older than these paintings. The Cave of Swimmers does not show the invention of swimming. It shows swimming that has already become common enough to be worth recording. Swimming is a skill that does not preserve in the archaeological record. Bones do not tell you whether someone could swim. Stone tools do not tell you. But we know that humans have been swimming for a very long time, because humans have been living near water for a very long time. A 2018 study by Dr. Curtis Marian at Arizona State University analyzed the coastal settlements of early modern humans in South Africa. Marian's team found evidence that humans were harvesting shellfish from the ocean as early as 160,000 years ago. To harvest shellfish, you have to wade into the water. To wade into water, you have to be comfortable in water. To be comfortable in water, you have to know how to move in it. It is a short step from wading to swimming. The connection between humans and water runs deeper than just food. Being comfortable in water meant being able to navigate coastlines, to explore new territories, to escape predators from multiple directions. It meant that water was no longer a barrier. It was a highway. Let me now look at how other primates interact with water. Chimpanzees generally avoid water. They do not swim. They do not like being submerged. There is a famous video of a chimpanzee falling into a moat at a zoo and drowning. The chimp could not swim. It panicked and sank. This is typical for chimpanzees. But not all primates avoid water. Proboscis monkeys in Borneo are excellent swimmers. They dive into rivers to escape predators. They swim with a dog paddle stroke. Japanese macaques swim in hot springs during winter. some macaques have been observed diving for food. A 2014 study by Dr. Ikuma Adachi at Kyoto University tested swimming ability in Japanese macaques. The macaques showed a natural ability to move in water, though not as efficiently as humans. So the ability to swim exists in some primates, but it reaches its peak in humans. No primate swims as well as a human. No primate can learn the front crawl, the breaststroke, or the butterfly. No primate can hold their breath and dive to depths of over 100 meters. Only humans can do that. Let me tell you about the human diving reflex. When you submerge your face in water, your body undergoes a series of automatic changes. Your heart rate slows down. Your blood vessels constrict in your arms and legs. Blood is shunted to your vital organs. Your spleen contracts, releasing a burst of oxygenated red blood cells. These changes allow you to stay underwater longer. They conserve oxygen for your brain and heart. This is called the diving reflex. It is present in all mammals. Seals have it. Dolphins have it. Whales have it. Humans have it too. A 2017 study by Dr. Erika Chagatai at Mid-Sweden University measured the diving reflex in trained freedivers and non-divers. Chagatai found that the diving reflex can be strengthened through training. Experienced freedivers have a more pronounced bradycardia, or heart rate slowing, than non-divers. Some freedivers can reduce their heart rate to less than 30 beats per minute while submerged. That is half the normal resting rate. The human diving reflex is not as strong as that of seals or dolphins, but it is stronger than that of chimpanzees. This suggests that our ancestors spent more time in water than the ancestors of chimpanzees did. How much more time is debated, but the difference is measurable. Let me now explore how swimming changed human history. Swimming allowed humans to cross rivers, lakes, and even narrow sea channels. It opened up new territories. It connected populations that would otherwise have been isolated. The colonization of Australia, around 65,000 years ago, required crossing a sea gap of at least 50 kilometers. That could have been done on rafts, but it could also have been done by swimming. A 2016 study by Dr. Michael Westaway at Griffith University analyzed the migration routes of the first Australians. Westaway's team found that some routes involved crossing deep water channels. Swimming was probably part of the journey. Swimming also changed the way humans gathered food. Coastal populations harvested shellfish, fish, and marine mammals. These foods are rich in the omega-3 fatty acids that are essential for brain development. A 2019 study by Dr. Stephen Cunnane at the University of Sherbrooke argued that the consumption of aquatic foods was a key factor in the evolution of the large human brain. The fatty acids found in fish and shellfish are the same fatty acids that make up the membranes of brain cells. You cannot build a large brain without them, and you cannot harvest those foods without being able to swim. Let me now look at how different ancient cultures approached swimming. In ancient Egypt, swimming was a common skill. Egyptian tomb paintings show swimmers in various strokes. The Egyptians taught their children to swim as part of their education. In ancient Greece, swimming was considered an essential life skill. The Greeks said that someone who could not read or swim was uneducated. Plato wrote that a man who could not swim was a fool. The Romans built swimming pools and considered swimming a basic part of military training. Julius Caesar was known to be an excellent swimmer. In ancient China, swimming was practiced for recreation and military training. Written records from the Zhou dynasty, over 2,000 years ago, describe swimming techniques. In Japan, swimming was a required skill for samurai. They developed a complete system of swimming techniques called suijutsu, which included swimming in armor, swimming while carrying weapons, and swimming in rough water. These independent developments show that swimming is not a single invention that spread across the world. It is a skill that different human groups discovered on their own in different places at different times. Wherever there was water, humans figured out how to swim in it. Let me tell you about the swimmers of the Pacific. The people of Polynesia, Micronesia, and Melanesia were among the greatest swimmers in human history. They crossed vast stretches of open ocean in canoes, but when their canoes capsized, they swam. They swam for hours, sometimes for days. They swam while holding on to children, supplies, and tools. A 2017 study by Dr. Alana Rogers at the University of Hawaii documented traditional swimming practices in the Pacific Islands. Children in these cultures learned to swim before they learned to walk. Swimming was not a skill. It was a way of life. In the Marshall Islands, ancient navigators used stick charts, maps made from palm fronds and shells, to read ocean swells. These navigators could detect the movement of waves from hundreds of kilometers away. They knew how to read the water in ways that modern science is only beginning to understand. Swimming was not separate from sailing. It was part of the same skill set, the same relationship with the ocean. When a canoe capsized between islands, the ability to swim meant the difference between life and death. Pacific Islanders did not just know how to swim, they knew how to survive in the water. Let me tell you about the neuroscience of swimming. Swimming is one of the most complex motor skills that humans learn. It requires coordination of the arms, legs, torso, and breathing. It requires timing. It requires proprioception, the sense of where your body is in space, and it requires overcoming a deep-seated fear of drowning. A 2015 study by Dr. John Ratey at Harvard Medical School analyzed the effects of swimming on the brain. Ratey found that swimming increases the production of brain-derived neurotrophic factor, a protein that supports the growth and survival of neurons. Swimming also increases neurogenesis, the creation of new neurons, in the hippocampus. The hippocampus is the part of the brain responsible for memory and spatial navigation. Swimming makes your brain better at remembering and navigating. This might explain why swimming feels so good. It is not just the physical exercise, it is the neurochemical reward. Your brain rewards you for learning a skill that kept your ancestors alive. The benefits go deeper than memory. A 2018 study by Dr. Sifina McSweeney at the University of Bristol found that swimming in warm water increases serotonin and dopamine levels in the brain. These are the same neurotransmitters that antidepressants target. Swimming is literally brain medicine. Let me now tell you about the limits of human swimming. How far can a human swim? How deep? How long can you stay underwater? The answers are surprising. The longest recorded open water swim is over 200 kilometers, completed by Australian swimmer Chloe McArdle in 2020. The deepest freedive without fins is over 100 meters, achieved by New Zealander William Trubridge. The longest breath hold is over 24 minutes, achieved by Croatian freediver Goran Kolak. These are extreme limits, but they tell us something about the human body. Think about Michael Phelps, the most decorated Olympian of all time. His body was not built for water. He has a wingspan longer than his height, double-jointed ankles, and a torso that creates less drag. He trained those genetic quirks until they became the most efficient swimming machine on Earth. The human body is capable of remarkable feats in water, feats that no other primate can match. A 2020 study by Dr. Jonathan Wells at University College London analysed the physiological adaptations that make human swimming possible. Wells identified several key features. Our upright posture gives us a streamlined body position. Our long legs provide powerful propulsion. Our large brains allow us to learn and refine complex stroke techniques. Our shoulder joints are flexible enough to rotate through a full range of motion. Our hands can be cupped to pull water. Our feet can be pointed to reduce drag. Every part of the human body is adapted for swimming, not by design. By accident, the same features that evolved for walking and running on land turned out to be useful in water. Swimming is a happy accident of human evolution. Your sweat glands, unique among primates, Cool your body efficiently during exertion. When you swim, you do not overheat because your body is immersed in water. But on land, your ability to sweat allows you to run for hours without overheating. That same cooling system, adapted for the savanna, works perfectly in the pool. Your body is a collection of adaptations repurposed for a world your ancestors never predicted. Let me now take you to the most surprising chapter in the story of human swimming. The Bajau people of Southeast Asia. The Bajau, also known as sea nomads, have lived on the water for thousands of years. They spend so much time diving for food that their bodies have adapted. A 2018 study by Dr. Melissa Illardo at the University of Copenhagen analyzed the physiology of the Bajau people. Illardo's team found that the Bajau have significantly larger spleens than the general population. The spleen acts as a reservoir of oxygenated red blood cells. A larger spleen means more oxygen available during a dive. The Bajau can hold their breath for up to 13 minutes. They can dive to depths of over 70 meters. They do this without any equipment. This adaptation is genetic. It is an example of recent human evolution. In just a few thousand years, the Bajau evolved a physiological adaptation that makes them better at swimming and diving. This shows that human swimming ability is not fixed. It can change. It can improve. It can evolve. Let that sink in. Swimming is not just a skill. It is a reminder that your body is capable of more than your ancestors ever imagined. It is a reminder that evolution is not finished. You are still becoming. The water does not care who you are. It does not care about your status, your wealth, or your appearance. It treats everybody the same way. It pushes back against every movement. It demands respect. And when you learn to move with it rather than against it, it carries you. That is the lesson of swimming. That is the lesson of being human. Let me bring this back to you. The next time you get into a pool, a lake, or an ocean, pay attention to what your body does. That first splash of cold water on your skin, your heart rate slows, your blood vessels constrict, your spleen contracts. Your body is preparing for a dive. Those strokes you use to move through the water, they are the result of hundreds of thousands of years of practice, passed down from generation to generation. That feeling of weightlessness, of freedom, of moving through a world that is not your own. It is a feeling that no other ape has ever known. You are doing something that your closest living relatives cannot do. You are swimming.